Hello Classpad.net users. Today I'm doing something a little different. I actually have created an activity, Quadratic Functions on the area of a garden. And this is an activity that's made public. You guys can share it. You can use it with your students. So what I wanted to do in this video was simply kind of work through some of these things to kind of explain what has happened, how this is using multiple representations to help students get a better understanding of a quadratic situation. We're not going to do the whole activity. I'm just kind of showing you how it works. So in my account, which is free, remember you can set up a free account, I've created an activity and I have saved it. I've given it a title. I've kind of color coordinated it. It's an algebraic problem, so I'm using pink for algebra. So all my texts are also pink just to kind of be consistent. I have shared this publicly. So to do that, let's remind ourselves, you go up to the three dots of the paper and go to share, and you'll see that I've chosen public, and that means I can give this URL to anyone and they can work on the activity. So my students, other teachers, and anyone who's in the Classpad.net world and wants to find an algebraic activity on quadratics could also find it because I've made it public. This is the URL that I would share with someone. I can use on my website, I can send it in an email. So right now I'm going to URL copy it to just show you what happens. So I've sent this URL, let's say I have my URL on my website, or I've sent it in an email or something to everybody. So what would a person who actually wants to use the activity do then? So I'm going to leave the original. So this is the original, lives in my account, and I'm going to go to another account that is now somebody who's using it. So all I have to do if I'm the user is take that URL, click on it if it's sent in an email, and put it up here in my browser. And what happens is a copy of the original comes up. And now I can start working on this copy. Notice right now I'm just a generic person. I'm not logged into an account. I can use this, I can work on this, I can do everything in it and do the activity without having to sign into an account. But if I wanted to save my work, so let's say I was a student and I did the work and I wanted to save it and send it to the teacher, I would want to be in my account so that I could save it, right? But right now we're just going to work as a generic person because we don't necessarily want to save it right now. So I just want to work through a couple things. So this is a problem where I've been given a set amount of fencing, 36 feet, and I have to cut the fencing, and I can use whatever lengths I want, so I can use decimal fractions, whatever, but I've always got to use all 36 feet. And the question is, if I want a rectangular area of my garden using that fencing, what are the dimensions of that garden? Notice it's not a very specific question. It doesn't ask what's the largest garden. It doesn't ask what's the skinniest garden, anything like that, because the idea here is we want students to make decisions based on what makes sense to them. So in theory, this problem could have multiple solutions depending on the reasoning of the student. So some might say, I would like the largest garden, so here's my dimensions. And some might say, I actually think maybe because my yard is long and skinny, I want a longer and skinnier garden. That's why I'm choosing these dimensions. So it kind of adds a little creativity to their solutions, but they still go through the same process. So here's what we are going to do first. So notice I have my text giving my directions, and then I have now statistics that I can do. I'm going to enter some data. So it says in the table to the right, record at least 10 different dimensions. So basically students have to use some prior knowledge about perimeter. I've got 36 feet of fencing. I've got to understand feet to inches conversions, those types of things. And I've already come up with some numbers, so I'm just going to enter my numbers. You would have students be working together on this, but let's just enter them. So it's statistics. I'm just going to enter my width measures I came up with. And notice the directions say that we want at least 2 of them to have fraction or decimal things, so I did half feet. And you also want some of the widths to be larger than some of the lengths, so that we're kind of diversifying here. So I have my calculations here. All right, so entering data is relatively easy, right? So as long as they've kind of verified that their perimeter adds up to 36 feet, those types of things. And you might even see students drawing pictures, which they could do. They could pull up a geometry sticky and do that if they wanted. The next thing is that, okay, we got this third column, we want area. I want you to calculate the area. Remember, these are rectangles, so hopefully they have some prior knowledge that the area of a rectangle is its width times its length. So they could do it each separately, or we could use our calculation tool to do this for us. Since this is Classpad.net, everything kind of talks to each other. I have area over here, and now I'm just going to get my calculate tool and define my area based on these other two columns. So my area, so notice I'm using the label up here, area, as it's written, and I'm going to define it. So to define something, you're using colon equals, and I'm going to define it based on these two multi-character variables. So I'm going to do width times length. And notice what happens once I do that, because I've been using variables that I've already kind of used up here, it fills in the table for me. So now I have all of my width, my length, my area, and the next step, so now we're going down, so we've done statistics, we've done some calculating, and now it says let's look at them, let's plot some graphs. Since we have a statistical table, we can now plot some graphs. So I'm not going to go through all of this, but basically they're going to plot two different scatter plots. So we're going to do width and area, and so choose those two columns and do a scatter plot. And then we're going to change and do length and area, right? And so also do a statistical scatter plot. And watch what happens as a result. I end up with two scatter plots that kind of look like they're overlapping each other, and this is a neat investigation for them to think, because they see that and notice that these little stickies here tell you which color coordinates with what. So this is length, red is the length in the area, X, and blue is the width in the area. So there's a couple points where they overlap, that's where it's purple, and then other than that, they're very close to each other, so they sort of have the same shape. So then students are going to go around and answer these questions, and they can write their answers in here. So everything's on this one page, which is really nice. So then after they've done their scatter plot and kind of analyzed and made a decision, so based on your table and your scatter plots, what dimensions would you pick? And again, since it's kind of generic, it's very open, they could pick, oh, I want this point up here because that seems like it might have the largest area, or it's the same point in both, so maybe that's the one I need to pick, whatever their reasoning is. So they come up with their reasoning based just on the scatter plot and based on the table, however they want to think about it. And then we're going to actually do some function fitting. So we're going to ask them to basically fit a blue function and a red function on top of these two. Now it'll end up being the same function maybe, but not maybe, definitely, but that's what we want to do. So for example, let's just plot the blue one. So after they've kind of done their calculations here, I'm not going to go through that. They would figure it out. They have to determine that area is going to be y, and x, if they do the first function, so the blue function is width, so x is width. So we're going to have to define length in terms of width, so that I'm only using x, right? So if I have to go back to my table now and analyze, so if this is width, if this is x, how could I describe length? Well, I know that altogether everything has to be 36, and if width is 9, and I have two of those, that's 18. To get 36, it's 18 minus 9. If you look, all of this kind of adds up to 18, so then I subtract from 18. So what's my function? So here's my function. So let's make it blue because I want it to fit. And I'm only going to do one, but it's y equals width times length, right? Well, if width's x, and then length in terms of width would be 18 minus the width, right? Let's see if that fits our function, and it does, right? So there's the blue one, and now let's go back and do the same thing for the red, and what they find out is that they end up with the same function, right? Because that makes sense, parabola, if one was length width, and they're related to each other, right? So the width's dependent on the length because we've limited it. And so then we can talk about, all right, so now what are some key points of this function? And where's my max and my min, are there any intercepts, those types of things. So then, of course, they're going to be answering questions based on now their function. Does that change the answer that you had up there? And then if you have students that finish early, there's extra challenges. So what if instead of looking for the largest or looking at the area as the deciding factor, maybe we want to look at the perimeter. Maybe we want a garden that has the largest perimeter. Does that change my answer of which garden dimensions I'm going to use? Garden plot dimensions. So it's just challenging. It's really helping them look at the data and how's the data going to help us, and how does that graph help us a little bit more or a little bit differently than maybe the scatter plot does, or than maybe the table does. So it's looking at different representations of data and information to get a decision, to come to a decision. So just an activity, fun to use. And now once a student has answered and done all their graphs, they can save it in their account if they want, send it off to their teacher. They have a separate URL, or if they don't want to save it, they just want to show someone, or they just want it to work, they're done. They close this out and they're done. And notice if I close this out, my original is not impacted at all because they were working in a duplicate of that. So this is just an example of an activity, how to share it, how to use it, how to work with it. And you can actually play with this activity. If you read the blog post, you will see the activity link.